Good morning, class. Today we will be discussing or expounding more upon the discussion we have left up last week, but also be adding upon our discussions on object-oriented principles. If you want to be able to continue upon our discussion today, in which we will be conducting hands-on, I urge you to download this repository, this one from my repository. I'm sure you're already following my account in GitHub. So I urge you to download the turn-based game. This includes most of the code of the turn-based game minus the complexities. It also includes some tutorials as well as commentaries on how each of the parts work. So this is just a continuation of our discussion last week, which is about learning the concept of annotations, method overloading, and encapsulation. So we will not be expounding more upon the annotations as this is already been discussed, but just an overview. Um, Annotations is similar to how comments work, with the exception that um, annotations provide metadata to the compiler. Metadata meaning it is the type of information that is not actually related to the program but will be useful for the compiler. Meta meaning outside, then data meaning data from the outside, providing it to the compiler. So we will not be expounding more upon the annotations, but most of the time, annotations are basically just the functions uh, for the compiler to understand. For example, if we this is usually denoted by the at symbol in which it will provide several suggestions regarding what kind of annotation to work around with. So, last week we have discussed upon um, method overloading and encapsulation. So, we uh, so this is the first principle of object-oriented programming, encapsulation. Today we will add upon the principles that we are going to learn, which is inheritance. So in encapsulation, it means that we are trying to hide or we are trying to encapsulate data, meaning we are trying to uh, segment the data into uh, various fragments in order for them to be more secure, order for them to be modular, in order for them to be useful by other projects in our library. So here we will be using the turn-based game as a basis for our program today. So I would like you to open it and I would like you to open it and rename it into your own. Basically, this will become a group activity. This will be included in Module 3 Activity 1. So now, as you can see, we will be trying to run this so that we can see how it actually functions. So now that I am running the program, let me just show this how it functions. Till phone. So this is the basic turn-based game. So there is a single button here for the UI, and it includes the basic statistics of both the player as well as the enemy. So the principle is really simple. In the first turn, a little explanation of the code. So let's start here and on click. Little explanation of the code. It starts with the turn counter, which is in here. Here, turn number. This variable is responsible for counting how many turns the game has. So the turn counter is being used to process or to give turns to the player and the enemy. This is also used in other turn-based games. For example, Final Fantasy, even Pokemon. So this is how um, turn-based ruling works. So upon a turn, there is an assigned unit in which he will either attack or defend. So to make this happen, I use a simple turn-based approach in which um, player 1 should be the first turn and the second turn would be the enemy. So to achieve this, we use the condition turn number modulo 2. This function allows us to count if the turn number is odd or even. So it is simple enough, right? Because there could be an odd or an even number at a given time. There's no middle ground between them. And it also alternates. So let's say 1, 3, 5, 7, or 2, 4, 6, 8. It is always alternating, right? There should be no precedence in which there should be two odds or two evens in a single counting of number. So in this first turn, which is if there is a remainder of 1, so 1 is our first turn, right? 1 is our first turn. So 1 modulo 2, there will always be a remainder because you cannot divide 1 by 2. So the modulo would be 1. So if we achieve this condition, the user would be the first one to attack. So to simulate the attack, we will reduce the health of the enemy by the damage the user deals. So we are using a randomized damage input based on 75 to 100. So let's do the first turn. So we dealt 85 damage to the enemy. You will notice it started off with a 1000 HP. So we dealt 85 damage to the enemy, which is somewhere between 75 and 100, then deducted it to the health of the enemy. Here's the how it is executed in the code. Then, after we dealt the damage to the enemy, we have basically ended our turn, right? We have basically ended our turn. So we added or we incremented the turn number by 1, making it 2, right? This is basically making the turn number to 2. So as you can see, the turn number is now 2. Thus, it will be the enemy's turn now. So upon enemy's turn, the damage should be either 100 to 150. So let's do the enemy's turn now. So the enemy dealt 140 damage to the player. Basically, this continues on until somebody wins. So I stop the turns here because the next turn will be a fatal blow to the enemy. So let's go to here to the enemy's turn first. Let's see if okay. So 148. Our next turn will surely be a fatal blow to the enemy. As you will notice, our damage is 75 to 100, but his health is 58. Meaning that we will be dealing damage more than his health has. So we have created another condition, a nested condition within the player's turn. So, if the monster has a health less than 0, so it will create a message in which the player will be victorious. Also, as you will notice, we have resetted everything. We have reset the health of the monster to its original values, including the turn number. So let's press this. So as you'll notice, uh, the HP of the monster went negative. So that's how basically the game turns out to be. Now, we will be recreating this and making this one, these variables into a separate class, or rather separate classes. We will also be implementing what we call inheritance. So, I would like you to create first a class here. So, beside main activity, we will be creating a class. We will name it game unit. So, game unit. I hope you're following. Okay, let me prepare so that. So, we will be applying a simple inheritance principle here in our code. So this we can be found in uh, Module 3, Lesson 3. This can be found here. A deeper dive into object-oriented programming concepts. We will be applying this because this is uh, appropriate scenario in which we can use uh, class inheritance. So upon this lesson here, you will notice that if we create an object in which we will be basing our class upon, you can make it so that an object inherits the qualities, or rather a class inherits the qualities that other uh, the base object has. It can have a subclass, it can have a superclass. So we will be learning how class inheritance applies. So let's go back to our code now. So you will notice here in hero class and as well as monster class that they are sharing some traits, right? They're sharing some traits that can be interchangeable with one another. You will notice that both the hero and the monster has health, right? So it is a shared variable. Both hero and monster has health. Both the enemy and the player has minimum and maximum damage. So meaning we could make this code a bit shorter if we can make a way that both of them can share the same statistics. So let's go into our game unit. We will be creating this class to accommodate those shared traits or shared statistics if you uh, go by that. So what are the shared statistics that both the player and the enemy has? So let's start with level. I'm sure you're already imagining, sir, do monsters have levels? In some RPG games, it has a level, right? So we will be including uh the level. So let's say level. Most monsters and players have their own names. So again, we will be adding the name. Then they are also sharing health, right? So let's include health. So int base health. Another one would be mana. Next one would be hmm, maybe armor. So let's add an armor. Base armor. Then we add the minimum damage per turn as well as the maximum damage per turn. So let's add int min dpt as well as int max dpt. So now we will be adding a constructor. As we have already discussed in our previous discussion regarding constructors allows us to use the whole class. So a constructor is a method that has a similar name to the class it belongs. Again, a constructor is a method that has a similar name to the class where it belongs. So, because our class name is game unit, then we will be adding the game unit. Sir, what did you do with this constructor? We call this a default constructor. It has no particular function and purpose other than to make sure that we will have no errors when we call it here in our executing class. Again, uh, this has no other purpose but to make sure that there will be no errors in our main activity class. So we will add it like that. Then we will be adding another constructor that actually serves a purpose. So to make this function like a method, our our other constructor, we will be adding uh the variables that we have already created. If you have any questions regarding our lesson, feel free to ask me anytime. So we will be first adding the unit name. So string unit name, then the base health, then base mana, then I don't think we need the armor for some of the units, right? So we will be adding a default for that. Then the minimum damage as well as the maximum damage. Now we will be inserting this data back here to our variables in our class. So we can achieve this by using this that unit name is equals to unit name. What we are doing here is that if we insert data in our constructor, for example, string unit name, it will pass it back here to our variables in our class. So this base health. Oh, then this that base mana. As a group, you will be modifying this according to how your turn-based mechanic works. So again, you will not be using this code as it is, but you will be modifying it according to your own statistics of, or if you have any kind of mechanic that you want to implement in your game. Some other games implement a six stat system, which includes vitality, endurance, and such. There are also simpler uh, mechanics in this, in which there are only three main statistics, which is strength, agility, and intelligence. It depends on you how you will be executing your turn-based game. So now that we have added this, right? We have added um, the unit name, the base health, the base mana, minimum damage, and maximum damage. As you will notice, the base armor and level is still grayed out. It is grayed out because we are not using it, right? For example, some monsters do not have levels, though other monsters, let's say bosses, do have levels. Some other games do not implement levels in their monsters, right? So let's just add a default value to it. Let's say this that level. For this instance, no, um, because we are not declaring level here, because we are not declaring the same variable here, the word this, the word this is not necessary. You will use this if you are reusing the same name. Again, the use of this is to declare that you are meaning, or you meant that you are calling the variables within the class. So again, this may or may not be necessary in this code at all. Same for the base armor. Though this is very this is still good. It's up to you if you are going to add this or not. Basically, the use of this is if there are similar or duplicate names in your uh, method as well as your class. So now that we have added the level, everything regarding the stat, I think that concludes our game unit. But as it is, you will notice, hmm, where are the statistics that you are talking about regarding the character, sir? I don't see it here. So now, we will be creating the hero class. So let's just create another class and name it hero. So in this class, we will be implementing what we call inheritance. Inheritance allows us to, let me just split the screen. Okay. Inheritance allows us to inherit some of the variables or the properties that a class that we intend to inherit. So let's say we will be inheriting some of the values or the traits the game unit has. For example, we want to inherit the level for our hero because our hero has levels, right? Our hero has a name. Our hero has a health and mana as well as an armor, even the minimum and maximum damage. So we will be inheriting most of what the what our superclass has. So this is what the principle of inheritance is. To inherit to inherit a class, we simply type implements. So now, sir, I think we have been using implements before, right? You will notice that we are using implements here to execute. view on click listener. Meaning that we are inheriting the view class in order to implement it here in our main activity. So again, we will be inheriting the game unit. So let's say public class hero implements the game unit class. So game unit. So now we are currently inheriting game unit. So how do we inherit game unit? Or rather, I don't think we are inheriting game unit now. I think we are okay. So here, you will notice, sir, I think there is an error here. Don't worry, the error will disappear when we will be using this one. So, let's say, what do you think is the unique characteristics that game unit has or doesn't have that we will need for hero? For example, hero implements what we call experience system, right? Meaning that each monster that we kill, they will receive a fair amount of experience in order to level up. So we will be adding it in XP or experience. What other unique trait that does the hero have? So again, the statistics. So let's say stat strength, then so now that we have our hero class, again we will be implementing the default constructor to avoid the errors. Then our functional class or our functional constructor. So public, then hero, then we will be implementing let's start with the string, the same one here. The string, unit name, int base health, then int base mana, then int min dpt, then int max dpt. So let's add another comma here. Because we will be adding upon new elements to this, right? We will be adding stats, str, ag, and it here. So let's create this too. So double stat. There is a comma here. You can drop down if you think your code is too long. You can drop down as long as there's a comma. So double stat strength, double stat ag, then lastly double stat in. Sir, are we not including XP? We will not be including the XP here because we will not be, of course, we will not be modifying the experience of the hero, right? We will just be using it if we killed an enemy. So we will not be using XP here. Rather, we will be adding it directly to our constructor here. So now that we have our constructor, we will be uh, we will be adding everything that we have created so far. So here, let's create super. Super meaning our like uh the one that we inherited with, which is the game unit. We are pertaining to our inheriting class or our, let's say, uh somewhat like a father. So here we will be stating super, or meaning the super class. If the hero is the subclass, then game unit is the super class, because we are inheriting the traits of the game unit, right? So this will become the super class and this will become the subclass. So super, then unit name. Then, as you will know, as you are going to notice, there is an error. Expected arguments, but not but found one. So we will be adjusting this. Let's adjust it a bit better. Super dot uh wait. Oh, I think we have implemented it wrong. So as you are going to notice here, this is implements, no? Um, implements is I think a wrong approach here, because this is intended for interface. So we will be changing it instead to extends. Extends and implements are different matters, okay? So I apologize for my mistake here. We will be changing this to extends. So now, if you're going to look at our code, we will be typing super, meaning we are going to inherit uh, everything that the game unit has. Then, let's start with the unit name. So, super dot uh, super dot unit name. So, this is similar to how we use this, the word this or the this keyword. But rather than calling what is not here, because as you can see, there is no uh, unit name here. This one is not here, right? So we are basically calling back the game unit variables, unit name. Sir, what is happening here? So when we added the code extends game unit, basically we are inheriting this one. It's basically like the code is here, but it's not actually here. Parang let's just say that we are inheriting whatever the game unit has, because we are extending to the game unit. We are inheriting the values, the functions, everything that the game unit class has. So instead of using this, we are using the keyword super. So super that unit name, then again, these are inherited values, right? So we will be using super for that. So super that base health is equals to uh what's the base health? Base health. Then super that base mana is equals to base mana. Super that base, okay, base mean defeat damage per turn, which is, and super that max, then max DPT. So this one is from our class itself, right? It's here, meaning that we will be using this as a basis. So let's just say um, this that stat str is equals to stat str this that Stat ag is equals to stat ag. Then, so we have pretty much used everything, right? Except for the experience. So we will be adding value to those we have not actually declared. For example, the level. The level should not start in 0, right? So let's just say it is level 1, then super, then armor, base armor. Let's just say it is still 0, then the XP should be also 0. So now, our hero class is pretty much complete. It is pretty much complete now. So let's try creating, or let's try using the hero class that we have created here to our main activity. So how do we use this for our main activity? Let's just say, as you will notice, there are variables that I intended to move to individual classes, right? So we will not be needing this anymore. So we will be deleting this after we have created our own hero class, okay? So for now, let's just move this aside. Now we will be calling the hero class. Again, to call the hero class, let's just declare hero, then name the variable of the hero or the object. Let's just say circebs. Then equals new hero. Then, as you will notice, there is no error here because it is calling upon the default constructor. That is what is happening here. If we have removed the default constructor here, it will cause, or rather, it will cause an error. It will cause an error here in the, let's just say like that. It will cause an error. You will notice there is an error because it is looking for the default constructor. That's why, even though this has no particular function at all, it makes sure that there is no error in our code. So now that we have created our own hero, let's just try to put everything here. So to declare this, let's just move the hero here in our next tab. So to declare hero, we first need to declare the unit name. So let's just say the name will be uh, among the students here. Let's try mm, let's just try Erica. Let's just name our hero Erica. Okay? Then there will be auto suggestions, right? In which variable next. So here we will see that the next parameter is base health. So let's just copy everything that is above. Let's just, or rather, we can create our own. We will make it more innovative. So 1,600. Let's just say her HP is 1,600. Then her mana, let's just say 100. Then her minimum damage, let's just say maybe 65. Then her max damage, let's just say maybe 100. Her strength level, we can maybe put 15 here, 25, then 10. So Now, you will notice that there is uh, naming here. The unit name is Erica, the base health. So that's how cool we are using a class is. That's how we use the class. So let's just uh, put this aside for now. We will not be deleting it, but we will be adjusting everything that covers the hero, the makes use of these variables. So now we will go down here. Let's make sure that everything that is being used by this hero or default hero is being fixed. So let's try removing this. We will see every error that we encounter, right? Okay. There are several errors. So we will mitigate that. Let's start with error number 1. So the hero name, it is looking for our hero name. Now we will just call this one. So circebs, then circebs dot, what is the, okay, unit name. Then for here, circebs dot, again we are referencing the HP. So we will be using the base cell. Okay. Then the minimum damage per turn and the maximum damage per turn. So we will be replacing it with that min dpt, and okay. So we have fixed pretty much the errors in the onCreate class. We will be moving on to onClick. So then the randomizer for the damage. So let's start with the max damage per turn. The explanation for how this one works is written in the comments, colored in green. So if you read that, you will hear about the explanation here. Okay, now moving on. So the hero HP, we will be changing it to circebs that base health. So let's just copy this. Now we have pretty much fixed everything. Let's try re-executing the code again. Let's just tilt the phone. Okay. As you can notice, everything is changed in our game, right? We are making use of our class already. I'm demonstrating to make sure that you can see that it is functioning according to our uh, specifics or our statistics. So that pretty much sums up our program. So let's just, okay. Before we add on more to this, do you have any questions? Any questions from the students here regarding our discussion? Before I summarize everything. Okay, none? Okay. Just a summary of what we are discussing right now. We are basically implementing both inheritance as well as encapsulation. Encapsulation enables us to encapsulate, or let's say fragmentalize uh, our various data in order for them to be usable for other classes as well as projects. Lastly, we have also discussed um, inheritance. Inheritance allows us to inherit or copy the properties of another class that we chose to inherit. In this case, the hero, the hero class inherited the game unit class. For the continuation in our group activity regarding this one, I want you to create um, the monster class to continue upon this. I want you to continue upon this using the monster class. Monster class will also inherit the game unit class. Again, monster class will also inherit the game unit class. There are several properties that we have not used in our code today. For example, base armor. We have not yet used this today, but we will be expounding more of this later on, maybe tomorrow, as well as the use of the statistics such as strength, agility, and intelligence, as well as the experience and the levels. So, um, that's it for now. Thank you for your participation, students. Have a nice day.